Welcome to the channel where all you gotta do is, well, get back to work because Italy trip is over and I still need to take this and make it into a ball joint holder on her, and then I can weld my control arm bars to that. So had a tiny little confusion, or I don't know, I didn't really have a plan when I left for Italy. So I decided I would just 3D print a little plastic doodad to see how I was gonna assemble this before it, because this thing press fits onto the ball joint, and then there's a snap ring that retains it kind of as a secondary retention. But I wanted to put this whole thing together and articulate the wheels and make sure that caster camber curve is same as what I have in the computer. It should be, but I make mistakes sometimes, you know. So anyway, I 3D printed this thing out. This little notch didn't used to be there because I kind of slid this thing together, and then I realized, hey, this snap ring, it's not going to fit on there. That's no. So, and I can't really get rid of this flange because that's where the doodad welds to. And I didn't really like chopping this out of here, but I thought maybe I could get the snap ring pliers in there and then get it on, which maybe you could, but you never get it back off without a grinder. And anyway, so I went to my not so favorite source of parts, McMaster Car. Not the cheapest, but they have everything, and they have solid models of it, and they have, you know, descriptions and pictures that are usually pretty accurate. So it's a pretty good source, way better than the Grangers of the world and stuff. So not sponsored by, you know, obviously, but so I went there and poked around in the pages for the snap rings, and I'm just going to put a double row circlip on there, so you can just, it's like a spiral lock, and it has plenty of clearance to everything. It's about the same thickness, like 5 thousandths less. So I'll just make this thing 5 thousandths longer, and abandon these guys and the snap rings, so which kind of stuck anyway. So anyway, I'm gonna get to whittling. First thing I'm gonna do is take this thing over to the chop saw, cut it off in, I don't know if you can see that mark there, but a little over 1 inch, because the saw is not perfectly straight, so I gotta leave a little bit extra on there. So I'll probably I may make 3 or 4 of these. I got 6 inches hunk. And the reason is I'm gonna make extras is I want to bore this ID out. So it's just a slip fit onto here instead of a press fit. Because once it's a press fit, it's gonna be pressing it on and pressing it off. And I may have to like take the thing apart and put it back together 26 times. So I'm just gonna make one. It's got to have these little this little thing sticking up here, which is a bigger diameter. I don't know if you can see that, but it has a counter bore to get to the snap ring. So anyway, I'll make 4 of them, and then I'll bore 2 of them oversized, and then when I tack weld it on there, it'll still slide together, and then the other 2 I'll use for reel, and I'll weld it together, and then once it's all welded together fully, then I'll put it back on the mill and bore it to the right size with the 2 thousandths interference that it needs. So anyway, I'm gonna get to work now. Okay, so that's what it looks like when it's cut. A little bit oversized, probably I got an extra 100 thou on it or something. So make 3 more of these, and then I'll go play on the lathe and the mill, whittle it up into something that looks like for reals. Okay, after a little bit of time on the Bridgeport, got one of these guys turned and whittled. It slides over there. Now this is a slip fit, but this is just for making sure all my calculations are correct. Okay, so I got this thing notched on my fancy fixture here. So thing slides in there like that. So I'm just going to do a little bit of deburring on here and get the, get a little chamfer around there, and then I'll tack it. I know I'm going to need a chamfer around here, so because it's going to be really tight in there. Look up in that area. So I knew that from CAD. So anyway, this piece is not going to get used, but I'm just going to tack it on there in an easy place, probably like right here and the opposite side. And then I can at least assemble it to my suspension, hang a wheel off it, hang a fender off it, make sure, make sure it looks appropriate, because the pivot point on this is very different than it is on a normal Mustang. And that's one of the things that you really can notice when somebody does a body swap from a newer car to a 67, or even if it's an old Camaro or something, is the wheel articulation looks wrong, and your brain will pick that up instantly. So probably shouldn't design your suspension around aesthetics, but if you can design your suspension to work good and not look like shit, probably better. So that's my attempt here. I think it's going to be fine, but I've articulated it in CAD and it looks good. But yeah, some cars, it's a dead giveaway as soon as they turn the front wheels. Like, oh, that's a body swap. That's got McPherson strut or some stupid ass suspension on it. Okay, so I got this thing tacked together here. Not going to hold a real load, but that's fine. Neither will that. So this is approximately how it's going to live. These lower bars are going to be pretty much horizontal at ride height, and this will have a couple of degrees of negative camber. So it's going to be sitting about like that. I got a little bit of clearance in there. Had to do a little bit more, grinding on this to give a little bit of clearance, but I got like, I don't know, 1.5 millimeters most places. So, and it articulates, corner wise. So this thing is a little bit, where the ball joint is up here is a little bit farther back to give the caster. So got to understand that this ball joint's going to be on a bit of an angle, just the way this upright came from BMW, and then the lower arm is going to go right below here. The factory setup, that didn't work out because they needed this stupid little deflecting thing. I don't know why anybody allowed that to happen, but anyway, this one, the ball joint's up far enough to clear all this and to clear that even at full bump, according to my CAD. But that's why sometimes I don't trust myself. I may do a little bit more rubbing on this in here, and then doing the same thing to this guy, like in this area here. See what it used to look like. That doesn't seem like a very good load path. Like this load path's going over to here and the bolt's there, so. And then this sharp corner is not doing anything, so. I could like theoretically redraw this stuff and put it in FEA and see what it looks like, but I'm not gonna. I don't know the material properties of this, and I don't really know what the loads are, but my car is going to weigh about 1,200 pounds lighter than that BMW did, so it should be adequate. And I'm also gonna, because, funny story, in my Birkin, which is like a Lotus Super 7 copy, I had the lower control arm, or the lower ball joint break on me while I was driving spiritedly on a mountain road that on off would have been bad. So I'm a little bit, you know, timid on the lower control arm and the lower ball joint. So I'm going to put a tether from here to here anyway. So in case this thing does break, it won't go far. Like it'll be bad. I will notice it in the steering, but the wheel won't come off. So I won't make the tethers long enough to let it fall off. But they'll be like from here to that. And then, yeah, it'll flippy floppy around if it breaks, but it won't go anywhere. Still probably not a great solution. Alright, so this is just a mock-up, so, you know, don't pick on my welds or anything, but it's kind of like there. Looks like a suspension. That's a little bit higher than ride height, but maybe an inch. So G by V and a little lower control arm. And it needs to go back a little bit. All the bushings aren't exactly symmetrical right now, but it's close. And that's nowhere near full articulation because it's hitting up here. This also has about 3 degrees of negative camber, which is a little bit more than I wanted. I think it could just be the slap in the bushings. So, well, not really bushings in there. Yeah, it's pushing on the outside of the tire here, so I think it's just flippity flop. I think my CAD is correct. Yeah, this is looking pretty much what I wanted. Okay, well, I've made a giant mess again. Pretty normal. But I think I did some measuring where the rack lives. Like this is in marker, that's what I measured, and then in CAD, that's what it is. So pretty close to an inch off here, and pretty close to 3/4 of an inch off there. So the reason that's okay is the relationship between where the wheel is and where the rack is kind of important, and I'm off by a teeny bit here, like 300 thousandths or so. So what I'm going to do is I'm going to shift over the flanges where the bushings go on the A-arms to get the wheel right where I want it, which isn't going to take much of an adjustment because I left a whole bunch of material on there anyway. So I can clean that up a little bit, and then this is in its correct position now for the wheelbase, the standard 108-inch wheelbase. So that's what it looks like, and it's pretty close to ride height, I think. So that's what it looks like. Got plenty of clearance here, meaning some, and then this edge is not rolled completely. It's rolled a little bit. It's not like straight in there like stock, but I'm going to roll that up till it's just 2 thicknesses of metal. I'm not going to do it with a pair of needle nose pliers or vice grips like my colleague at Lark Avenue Mobile did it. back in the 80s. I mean, it fixed the problem. It just made it look like a moron did it. But and then I have a little too much negative camber. Not 100% sure, but that's like 4 degrees. It should be 2-ish. So I'm gonna have to do a little bit more measuring on here and see why that is. I 3D printed some bushings to go in there to replace the bushings. Let's see, where are they? Yeah, right there. So I mean, there's a little bit of slop in there, but they're pretty close, within a millimeter probably. So I mean, it looks kind of good with -4 degrees, but it's gonna chew up tires. So I got to pull a couple out of there. My original plan was to make basically the aluminum adapter that goes into the McPherson strut thingy, a little adapter that goes in there. It was on a previous video, I showed it, but it goes inside, yeah, inside there. So I was going to make that off center, and then you could adjust it. So you could put it forward, back, change caster camber. It changes caster and the camber at the same time, but caster's kind of less important, in my opinion. So I can adjust there's means to adjust the top, and then I can change the camber curve by moving that in and out, or getting a ball joint with a longer stick out. So that is my adjustment. But the lower control arm, you don't want to put an adjustment on the lower control arm, because that has all the force on it. Or that has the majority of the force on it. There's some force on the upper one, but the lower one is the majority of the force. 85% of the force is on the bottom one. So you don't want that one to be the one you're adjusting. But anyway, this is yeah, this is looking pretty darn sporty, I have to say. Plenty of brake, I think. So yeah, now I just need to, now that this one side is in, I need to make the other side perpendicular, and coming from my 0 point in the rear, I just arbitrarily picked a 0 to make, you know, in CAD, so it's the same. But I think this is going to work. I think I may have to, like this thing is kind of tweaked here, which really needs to be, you know, kind of out like that. So I may need to do a little bit of body work on that to make it clear, because the way it articulates it. Let's pull this out of here. That's just my safety bricks. But if I rotate this over this way, got lots of room over there. But if I rotate it, yeah, if I rotate it that way, this needs to come up like that. I think it'll be fine though. So, and I need to get the fender in its proper position and less tweaked and stuff like that, but I don't think that's a big problem. I think we're real close. And if this is right, my Ackerman's right, and bump steer's right, and camber curve is right, I just got to figure out why my negative camber is a wee bit off. Okay, so this is just a mock-up, so this is the exact time that you want to find this out. But if you look at that, this thing's got like 4 degrees of negative camber, which is way too much, actually. Like that. So that's way too much. So not sure what's wrong, but this is all custom everything. So upper controller and lower controller mounts. I'm using this upright, like from the BMW. That's not really made for this, but it's all in CAD, so everything should be correct. But you know, people screw up. Anyway, so what I did to science this out is I pulled the bottom bolts out of the control arms. Excuse me, there's the guys right there. And I pushed this wheel in, and I looked at how far it was off to get this to in the range of 2 degrees, a little over 2 degrees. So, and that was about 9/16 of an inch. So then I went into CAD and I, looked around and tried to figure out if I made that control arm narrow, shorter, what that does to the bump steer and stuff, and it's not great. So I came out here just as a kind of a last resort to science out whether maybe I just made it wrong. So from the center line of this guy to the center line of this guy should be 12.44. And it's 12.9. So that's the exact number, 0.56 inches. So somehow, when I put these dowel pins in here, I must have dialed the wrong number, or I don't know. I don't know what I done, but I done it wrong. So that's good. So that means my original CAD is correct. This fixture's correct. I just need to either get rid of these pins and just move this thing over 9/16 of an inch approximately. And then I'll leave this guy's already welded to here, just tacked, put it back in the fixture, remachine that 2.5 inch hole saw chingadera there, and then I should put it back on, and it should be caster, camber, bump, Ackerman, everything correct. So sometimes you just gotta like take a step back and go, okay, it was 2 days since I figured out that I had too much negative camber in there. So I went on to, think about it and think about other things, and, get up the gumption to come out here and start measuring stuff and see what's cattywampus and what's right. And, So anyway, I did make a mistake, as usual. It's human error. It's easy to fix. I just need to change my fixture a little bit, and then I'll be back in business. So, yeah, don't just send it. Like, I know it looks cool on the internet when you completely screw everything up, but yeah, tack things together like that. That's only got like a couple of tacks on it, but it's enough that I can, roll it around and articulate it, and see that it bumps into the fender here, but not here, and see that my negative camber curve is gonna, this thing's gonna roll up like that because its instant center is, it's down there somewhere. So, where these two imaginary, come together. So, anyway, that makes me feel a lot better. I'd rather not just take 9/16 of an inch off of the control arm and not know where it came from. So, turns out that's exactly what I'm going to do. But it'll make it like to the CAD number, not fudged. So, yeah, never say never. When you're at the track and you got a sledgehammer in your hand and, you got to get it done, it's different. But if you don't understand what the problem is, go do something else. Think about it and until you do, and then come back to it with a fresh mind. Otherwise, those errors compound each other, right? Like if you just like change it and don't know what the problem is, now you get the whole car done and it has so much bump steer you can't drive the thing. So, or, murders the inside of your tire. If you leave it like this and you got 4 degrees of negative camber, that's going to be an expensive mistake because it could well work on the track, but this wide of a tire, your camber curve has to be pretty darn good. Like if you're running 195s, it doesn't matter. You got enough side flex that camber curve, yeah, it'll fix itself. Okay, so I scienced out what I did wrong. Multiple things probably, but I meant to cut this edge here so this was tangent to that. Somehow I screwed up. When I was machining it, happens. So I went back to my CAD. It was actually 400 thousandths different from there to there. So I just put this 1/2 inch block on there, measured 100 thousandths from there to there. So it should be shifted over 400. And then I drilled some holes in my fixture here so I can put some proper strap clamps on it instead of, you know, MacGyvering it. Indicated my plastic 3D printed fixture doodad back on there. And so I just kind of ground the welds off of there, and we'll reuse that other piece. We'll tack it back on, mock it all back up, and everything should be, you know, perfect. Okay, so 15th time off with this wheel and tire and brake. Negative camber is right back to where it's supposed to be. I think it's like 1.7 degrees right there, something like that, which is as designed. Nicely centered in the wheel well. And it spins, so that's good. It doesn't do... It's got a lot of inertia. It doesn't do full rotation this way because it's hitting a clamp, but it'll go a little bit more than that. Looks like we got plenty of clearance in here. And then similar. Now this isn't like in its proper location. I think we still might have to do a little modifying against that. But it's real close. Close enough within the adjustments I have. I mean, obviously the fender's not bolted on perfect and all that, but I'm just making sure I'm not off by 400 thousandths of an inch. 10 millimeters to some people. So yeah, there's a lot of exposed tire there, which I'm okay with. And this has like 5 inches of ground clearance to the frame rail there. Which, if I go any lower than that, that's gonna be pretty aggressive, going over speed bumps and whatnot. Nothing worse than a car that you can't drive, so. Okay, so now that I have that control arm made to the proper length, I did a full articulation of it. So this is at full droop. See, there's a mile of clearance in the fender here. And I measured the camber and every 1/2 inch. And wrote down what it is, so I can compare that to my CAD model. Not going to be exactly the same, but it should be perfect. But so I have 2.5 degrees of positive camber at full droop, 3 inches of droop. So I have 5 inches of suspension travel total, 3 down, 2 up. So yeah, this is looking very close to what I wanted, so that's good. One thing I do want to change though is, see if I can get in here and focus on it. So I have the suspension arms going above where the position of the ball joint snap ring is, and I'm gonna change that. And the reason for that is it's this little part sticking up here gets in the way of allowing the tire to go all the way in here to get full turning radius. And these tires are super wide, so I'm already kind of limited by the turning radius, but I want to get as much as I can. I don't want to be limited by this. So I've actually ordered a new piece of material here. Instead of 2 3/4 diameter, I ordered a piece of 2.5. And then these bars are going to go down here. So I got plenty of room down here. So I'm going to have to remake those pieces I made last week, which is no big deal. It's more important that I have the turning radius that I need. And you can draw this stuff in CAD till the cows come home, but once you build it, it's different. It's just different. You can see more stuff. You can hold it in your hand. You can articulate it around in real time, and it's a good place to start. Like I'm a very big proponent of starting in CAD instead of just like building it, because you can change stuff in CAD. You want the suspension arm to be 1 inch longer, a 1/2 inch longer, whatever. You want to change your caster camber, Ackerman curve, whatever. You can do it all in real life. I mean, in like quick time. You don't have to like spend a week building it and ordering parts. So you can get really, really close in CAD. But the last 5 or 10%, you just have to build it, and you gotta. The problem, and this doesn't happen just in my garage. This happens in the real world as well. Like you design something, you order the parts, you get the parts in, you assemble, and you go, oh crap, I don't really like this. Too late to change it. Boss doesn't want to change it. Everybody says, ah, that's good enough. And then once it's in production, it's super hard to change it. It's 10 times harder to change it in production because people already have a fixture to assemble it, and bill of materials, and supply chains, and pricing worked out. And so if you can get stuff fixed before it goes into production, it will save you man years of time. So anyway, this maybe is not going to save man years, but this is going to make the product better, because I need all the articulation I can get up here for not that it's a drift car or anything, because that wouldn't be very good, but I want to get as much articulation out of it so the turning radius is low, and if you have to correct on track, the more steering angle you can put into it, the better. So I'm going to fix this. It's going to take me an extra couple weeks. In the scheme of things, not so much, but I definitely, you have to have a high standard, or else your standards, once you start lowering your standards, it's not good. So anyway, okay, so today I decided I would double check, and now that I know the ride height and camber curve is good, I'm checking the bump steer, and then after that I'll check Ackerman. But this is the way I checked bump steer. So instead of trying to measure to the center of the wheel, I just put an angleometer on here on lower control arm, because at ride height it's approximately, I think it's like 0.6 degrees or something at ride height, and then it moves a couple degrees from there up and down. So basically what I did, just to get a kind of a reference of where I'm at, is I just went every 1/2 degree and measured the distance from the inside of the rotor to here, the back of the rotor to here, and then I could get an idea of what the bump steer looks like. And the first time I ran that, it was not great. It was, well, those are the numbers there. But you see, well, this isn't a line, so if we aligned it, it'd be this. But it changes not so much from here to here, but in here it changes like 5/16 of an inch. Which, yeah, that might be adequate. But then I started doing some measuring, trying to figure out if the placement of the rack is exactly right and all that stuff, because it's kind of challenging to get everything. Like, I don't have actual dimensions and tolerances for this guy, so I had to, kind of measure it. Anyway, so not being happy with that, I did a bunch of sleuthing and measured stuff, and I came to the conclusion that I needed to raise this up about 3/8 of an inch. So I stacked some washers under here. You can see that. Stacked some washers. Bolted everything back down. The other thing you have to do is you have to make sure the rack is centered. So I got the rack centered, because where it pivots, the pivot point here and the pivot point of the rack is very critical in making the accoutrement work. So I did that, and then I reran my cheesy test, and this is what I got. Almost zero change in towing from that travel. So that's pretty good. I mean, you really only need it to be good within, you know, plus minus an inch or so, right? After that, like, you're going around a corner and one's gonna go this way and one's gonna go that way. So, but this is really good. Like, let me explain a little bit. Like, well, this is 11 5/16 and this is 11 5/16 plus. That's because I don't, you know, it's fraction, so it's like on the plus side of 11 5/16. So it's almost 11 3/8, 32nd. But yeah. So anyway, you can see there's a couple of, you know, there's a minus here, plus here, not here. You know, so it's all within kind of a 1/16 of an inch. Like, this is only one side, right? It's going to be the difference on the other side. And then this is just the wheel. This isn't like towing at the outside of the wheel. This is tow at the rotor, from this side of the rotor to this side of the rotor, right? So you got a double, well, this is 14 inch and those are 25. So a little bit more, 40% more. So anyway, but this is really good. This, I mean, if this is a Formula 1 team, probably not good enough, but way better than most race cars are. My personal opinion, I could be wrong. Thanks for watching. If you like this content and want more, subscribe, like, and share.